All right, 1 says the polynomial function p is given by which of the following statements is true about the end behavior? So remember end behavior, we look for the biggest exponent, which in this case is odd. That means one's going up, one's going down. And it's a negative, which means it's rising left and falling right. So because the sign of the leading term is negative, and it is, the degree of the leading term is odd, which means you could have ruled out A because that one didn't work, and C because that one didn't work. It is rising to the left, so it's going to positive infinity on the left, and it is falling to the right, so it's going to negative infinity on the right. This is the reverse.
So when it's negative, it starts with
Negative is up, left, down, right. And then it switches if it's positive. And if it's positive and even both up, and positive and negative, positive, yes. No. Even and positive both up, even and negative both down.
Okay.
Yes. Yep. All right, number 2 said the depth of the water in feet of a certain place in a lake is modeled by a function W. The graph of W shown where T is the number of days since the first day of the month. What are all the intervals increasing and at a decreasing rate? So you're looking for concave down, but increasing. Yeah. So concave down only here, right? But you want it to be increasing, which was there. Yeah. Not here. Here, sorry. All right, 4 says the polynomial function p is odd. So first of all, it's important to understand what even and odd are because they could like that this could get interchanged with even. If p of 3 equals -4 is a relative maximum of p, which of the following statements about p of -3 must be true? So p of 3, 1, 2, 3, -4 is a point over here, and it's saying it's a maximum, which means there are points below it. Odd means anything that happens here flips to happen over here. So if I have a coordinate point that is 3, -4 here, then it becomes -3, 4 here. 1, 2, 3, 4.
Wait, what is odd?
Odd is symmetric to the origin, but it flips, like first quadrant goes to third quadrant, second quadrant goes to fourth. It goes diagonally in the other direction. So if this is your minimum here, okay, no, if that's your maximum there, it flips in entirety and becomes the minimum here. So if you don't see the flip, then think about the fact that anything in here, right, if this is my max, I have to have a point that falls below it. Whether it's to the left of it or to the right of it, doesn't matter, but it falls below it. So let's just say I had a point that was 2, -5. On the other side, it's going to become -2, +5. -2, +5 is above that point. So that rules out the fact that it's a maximum and that it's a maximum. And then it leaves me that it's a minimum, right? Whether it's -3, 4 or -3, -4. You switch the signs on both of them. So I switch this sign and switch that sign, which is why it's the other way around. It's this one.
If it was even, it would flip.
If it's even, it goes left to right. So if it's even, it's symmetric to the y-axis. So if it happened over here, it would happen over here. So even means y-axis.
Still be a maximum.
It would still be.
Wait, so odd you flip that?
Odd, you flip diagonally. Even over the y-axis, so left to right. Odd also happens like, let's say you have an equation that's like x to the third plus 5x. The way you check even and odd is you plug in a negative. If the negative goes completely away, it's even. And if the negative changes what was originally there, it's odd. So like if I plug in a negative, I get negative x to the third minus 5x. So this would be odd. Whereas if it said something like x squared plus x to the fourth, if I plug in a negative,
If it goes back to
it goes back to the original, it's even.
and if it doesn't, then there's no symmetry.
And if it did, correct, if only part of it changed, then there's no symmetry. Then, it says neither, even, odd, or neither.
Yeah, yeah.
Okay, 6 says, the figure shown is the graph of polynomial function. Which of the following could be an expression for g of x? So the things you want to pay attention to are the zeros. There's 1 here, there's 1 here, there's 1 here. And the one all the way on the right bounces, right? What's a bounce mean? Even exponent. So this would be odd. This would be odd. If you look at your answer choices, this looks like it's obviously the closest one. If all my values, if I look at them all, 1 is the smallest. So if that's 1, then this is the one that's a little bit bigger than it. Look at the other values, that would be 5. look at these other values, this would be 8. That's the one that's furthest. So it would be x minus 8. Nope, x plus 8 because it's on the left. X minus 1 and x minus 5. And this one had to be raised to an even exponent. That's the only one that had that.
Also, like, even if you could just look at the signs of the signs.
Yeah, it was the only one that had the right. No. A had the right signs too. You needed the exponent and the signs, but you could have at least narrowed it down to those two. Yeah. The other thing is these could have been to the third. So be careful. Like that could have also been an option. It's not there, so it didn't matter. But it could have also, it just had to be odd to cross through. If it's to the third, what? Well, you probably would have more turning points. That's all. So that gives you like, that would have given you more zeros, which means more turning points. Yeah.
Okay, you did number 9.
Okay, 7 says the table gives values for polynomial function, let blah, 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 where A, B, and C are constants in the xy plane. The graph of G is constructed by applying 3 transformations to the graph of F in order. Horizontal dilation by a factor of 2. So if it's a factor of 2 and it's a horizontal dilation, what would you be doing? Multiplying all your x's by 2. Then it says a vertical dilation by a factor of 3. What's a vertical dilation going to be doing? All the y's by 3. And then it says a vertical translation by 5, which is up 5. So whenever after you multiplied by 3, then you would add 5 to them. So if it says what's the value of g of -4, -4, first of all, you have to change these because it's not just -4 anymore, right? And then you'd have to multiply it by 3 and add 5. So this becomes -16. This becomes -8. This becomes -4. That's the one you'd be picking. So you'd take your 5, you'd multiply it by 3, and then you'd add your 5. So the trick was changing both, really, but not all of them. Like I wouldn't waste the time changing all of them. Yeah. Because then it would have been a factor of a half. So in the equation, the b is a half, but the actual dilation is by a factor of 2. If it gives you the factor, you keep it as it is. It would be, if it was in the equation, it would have been a half times whatever x is. That is a factor of 2. You're welcome. Other questions?
Like, I was just gonna ask her. Like,
Which one's 9?
Oh.
Yeah. So this one's geometric, right? All right. So it's not only, I mean, because you can treat it as geometric and also like it comes back with exponential. So they kind of go back and forth. So this says the values of the terms of geometric sequence are graphed in the figure. Which of the following is an expression for the nth term of the geometric sequence? So for geometric, it's A0 or A1, depending on the exponent, r to the n minus 1. That's like your parent function. So if I shift this, then I shift this. So if you look at your answers here, your A1 is actually 8. So that, the only A1s that are 8s are those two, right? But even with an A1 being 8, this would have to be n minus 1. So that rules that guy out. And then you want to find your rate of change. Your rate of change from here to here to, nope, 4, sorry. 4 divided by 8 is a half. So now your r is a half. Yeah. Okay, so how did it rule out? C. Because this, in order to use your A1, which would be when 1, it's 8, right? As your first term, your exponent has to be n minus 1. So as you move from A1 to A2 to A3, your exponent gets reduced. So if I go to the next one, then it would be n plus, like minus 2 and n minus 3 as you keep moving. So this is not an answer choice. That one doesn't work, right? So what happens here is I'm going to 4. 4 is A2. So A2 would be r to the n minus 2. A2 is 4. And then r is 1/2. And it'd be n minus 2.
And you find the r by doing
The r, yeah, well, yeah. Especially this is, they're like literally, they give you every single term. It's not like they're jumping. You just have to pick any of them and divide by the number before it.
So we just
Yeah,
have to-
R is the proportion that you're changing it by, what you're multiplying by every time.
We're just plugging in numbers.
Until you find the one that matches. Yeah. Like if it was an open-ended question that said find AN, then my answer would have been this one, 8 to the 1/2 times n minus 2. I mean n minus 1. But that's not the only right way. You can now take that and shift it back. I could do A0, which if I had at a 0 point, I could have done that, and it would have been that value times 1/2 to the n. Or I shift it forward, and each time you shift it forward, this number changes. So that's my A1. If I go to A2, that becomes 2. If I go to A3, that becomes 3. It's been a long time since we did these, but we did, yeah. You do the second divided by the third, or the fourth divided by the, like you keep going backwards. So I can grab any pairing and then take the second one and divide it by the first one. R was the common ratio. Yeah, you remember? And then D was the common difference. So that's geometric. D is the common difference. If it's arithmetic, it's A1 plus D times n minus 1. That's arithmetic.
Is there gonna be that
Sure, that's on your topics.
like tomorrow though, or like?
Yeah, but we also did those with a linear, like you could do those with slope. I think it was easier to do those with slope.
It's being divided by 2.
Yep, like this was on whichever practice exam had your row of chairs in the auditorium. Do we remember this from last week? So that was on the first 5 steps. Like the rows of the chairs were going up by 5 every time. That's arithmetic. It's linear, but it's also arithmetic.
And this is geometric?
This is geometric, which means you're multiplying by the same thing every time. Yep.
So if you don't know that formula, could you use like slope?
Not, you mean for arithmetic? Yes, for arithmetic you can use slope because it's linear. Yeah. Yeah, y1, or you could do any of those, like y2 minus y1, that whole thing. Yeah. This is similar to exponential, but those equations get a little bit different.
It's like you need to know the formula.
All right, this says, what are all the values x for which ln of x to the third minus ln of x equals 4? So these are your log functions. Remember, we would have to, if there's multiple logs on one side, we got to condense it down. When you condense, it's subtraction becomes division. And then ln is the same as log base e. This would actually simplify to be x squared equals 4. And then e to the 4th would equal x squared. So if I wanted to know what x was, I'd have to square root both sides. And the square root of that e to the 4th would become e squared. All right, 13, half-life is 8 days. In a particular sample, how many can be modeled by a function? Here's my function, okay? Which they already did the half-life. Remember, half-life, you would divide by however long it takes you to get to the half. If A0 is the amount of iodine in the sample at time D of 0, which of the following models the amount of iodine 131 remaining after T hours, where A0 is the sample at time 0, and there are 24 hours a day. So the first thing is that what it's saying to you is that it's after hours, right? And it's trying to tell you, like, well, this says, hang on, where the amount of sample, T is hours. So each day is an hour, which means 24 hours a day times the 8 days is how they get the 192. So that's the only thing that changed, was that it converted from days. So you didn't even need to know the half-life formula, but that is it. All you need to know is that it was given to you in days and the formula used hours. No, other way around. The new formula used hours. The original formula was given to you in days. All right, let 1 plus 3 secant x and g of x, well, that's the f of x. G of x is -5 in the xy plane. What are the x coordinates of the point of intersection of the graph? So if you need, if I know that this graph is based on what? It's based on the reciprocal of cosine, right? So if you wanted to know where, you could actually just set this equal to 5. 1 plus 3 secant x. And then I would subtract the 1, negative 6 would equal 3 secant x, and then divide by 3. Not negative 3, 3. And secant of x equals negative 2. And we probably don't have memorized your secant coordinate points, but you should your cosine, which is the reciprocal. And then knowing your unit circle, cosine is 1/2 at the over 3's, and the over 3 where it would be negative 1/2 is on the left-hand side of your graph, which is 2 pi over 3 and 4 pi over 3. So even though it's talking about the point of intersections on the graph, you could just like solve it algebraically. If you had a calculator, then you could do it that way, but it would be, you'd have to restrict your domain. Otherwise, it's going to happen a whole bunch of times. So make sure you pay attention to that stuff. That won't happen tomorrow because you're not having your calculator, but next week, they'll usually give you a restriction on those kinds of graphs. Otherwise, it would happen more than once. Yeah.
This doesn't have to do with this, but when we're like restricted, when it's like tangent and then sine on one side and then cosine is like
The inverse stuff.
when would it ask like questions where we have to use those restrictions?
So if it literally is in print already, tan -1 of something, or sine -1 of something, or cosine -1 of something, that's when you, if the paper says the -1, that's when you restrict it. Yep, if it said tan of x equals √3, then I'm using my full unit circle unless they tell me otherwise, right? So if I'm using the interval, then this happens at pi over 3 plus n pi. If it tells me specifically from 0 to 2 pi, then it's pi over 3 and 4 pi over 3. So you just got to pay attention because this does not mean you have to restrict the interval. We inverse tan it to get the answer, but it wasn't originally part of it. This is when you have to restrict your interval. I feel like that's going to happen on the FRQ more than the multiple choice, but sure, you could definitely see it. And it's guaranteed to happen on the FRQ. Yeah. This is sine and cosine's the top, and it's the natural first and second quadrant. You don't have to mess with those. But sine and tangent go from negative pi over 2, negative pi over 3, negative pi over 4, negative pi over 6, 0, and then the regular ones in the first quadrant.
So it'll be like, where's sine -1/2 and you say -pi?
No, it would say sine -1 of -1/2. And that answer happens at negative pi over 6.
You can't say 11 pi.
Nope, and if that answer's there, it's wrong.
Can
I don't know if they'll try to trick you, but I would think yes.
Can you scroll back to the minus?
All right, which of the following is the graph of the polar function where 3 cosine theta plus 2? So first of all, if it's cosine, okay. First of all, if it's cosine, the first thing I would do is look to see if any of them are different with the symmetry. So cosine is symmetric to the polar axis. So I would look to see that they could be folded. They can all be folded top to bottom. But if there was anything that was like, right to left, I would eliminate those because that would be sine. Then I would say, what kind of polar function is this? This is a limison. So if it's 3 cosine theta plus 2, the A is the one that's separate. So even though a lot of them look like this, like 2 plus that, the A is the one that's separate. So A is 2 and B is 3. And then A over B is 2/3. And the ones that have an A over B less than 1 are inner loops. That means I eliminate this guy and this guy. And now I'm just looking at the bottom two.
Also, since A is less than B, it's
Since A is less, but not just, yes. But yeah, it's because the whole thing is less than 1. But yes, that works too. But then you have to figure out between those two, right? And the other thing to look for is your max and your min. Your max comes from A plus B, which would be 5. So if I look, this is the only one that goes all the way to 5. That means I rule out B and D must be my answer. Let's say they both went to 5. I would look at the min, and the min is A minus B, 2 minus 3, which is -1. And that -1 also happens here. So both of those things confirm D is the shape you're looking for. Yeah.
It's kind of general. Can you go over how the radians, like not radians, but like the angles work for the negative, for the inverse cosine tangent?
You mean how you restrict it? Roses have a number being multiplied by theta. So a rose would say R equals like 5 cosine 2 theta or cosine 5 theta. They have a number there. That's how you know it's a rose.
Can it be like
No. I mean, in general, in the world of them, sure, but not in this stuff. Yeah. If this number is even, then it's equal to the number of petals. So odd, sorry. If it's odd, it equals the number of petals. If it's even, then we double it.
And the 5 at the front.
And if it's even, it has all three forms of symmetry. It has polar axis, pole, and pi over 2. Whereas odd just falls under the sine and cosine rules. And then the number on the front is the length of each petal.
And it was something like,
Is pi over 2. Just picture like sine is the y and the y is the y-axis.
yeah.
Cosine is the x and it's the x-axis, which is called the polar axis. So if it uses words, it's pi over 2 and polar. But if you're visualizing it, sine is the y, cosine is the x.
And then for the radius, it's the first term.
That would be the length of the petal. Yep. Mm-hmm. All right, 18 says, what are the values of theta from negative pi to positive pi for which 2 cosine theta is greater than negative 1 and 2 sine theta is greater than root 3? So I'm going to solve them separately. And I'm going to say cosine of theta has to be greater than negative 1/2. And I'm going to say sine theta has to be greater than root 3 over 2. So if you think about where this happens, to me it's easier to see a unit circle than it is to see your like curves. So where it's less, where is cosine equal to negative 1/2? Over 3. 2 pi over 3 and 4 pi over 3 normally, but look at my interval. It's from negative pi to positive pi. So these I treat as the negative angles. So it'd be negative 2 pi over 3 down here. That's where it's equal to negative 1/2. Now where would it be bigger than negative 1/2? What part's bigger on my x values? This side or this side? The right side. So it's going to be bigger than 1/2 all the way around here. Then the second part says sine is greater than root 3 over 2. Where is sine equal to root 3 over 2? Pi over 3 and 2 pi over 3. Because it's sine, right? So it's the y. So where is the y bigger than? All the way up here. These values here, it would be bigger, right? So I literally only want where it overlaps from 2 pi over 3 to pi over 3 or pi over 3 to 2 pi over 3. So 19 says the polar function is given by r equals f of theta negative 1 plus sine theta as theta increases on the interval, which is the following is true about the points in the graph. This is the same, like the language here says getting closer to the origin, getting further from the origin. This is talking about the distance from the origin. So remember, these are your rules on is r positive and increasing, r positive and decreasing, r negative and increasing, or r negative and decreasing. That's what you're looking at. So in each of those cases, you want to know what the values are at these angles. So I will find negative 1 plus sine of 0, and I will find negative 1 plus sine of pi over 2. So negative 1 plus what's sine at 0? 0. So this is negative 1. Negative 1 plus what's sine at pi over 2? 1. So this is 0. So what's true about these values as it's going from negative 1 to 0? Are they positive or negative? They're negative, so my r's are negative. Are they getting bigger or smaller?
They're getting bigger.
They're getting bigger. They're increasing. So if it's negative, but they're getting bigger, am I getting closer to the pole or am I getting further from the pole?
Decreasing.
The distance is decreasing, which would mean what? Closer or further? Closer. So now I can eliminate these two because I need it to be closer to the origin. Okay? Now it says the points on the graph are above the x-axis, or below the x-axis? And this is where it's important to say that it said in the xy plane. Because in the xy plane, so on your regular coordinate grid, where would -1 be? Below the x-axis, where would 0 be? On the axis. So where would the points be if they're getting closer to that one? Are they below or above the x-axis? They're below. So it is C, right? Below that, yeah, C. So it's not the polar axis, it says XY, and that's why it's confusing. Because if you look at your curves, your R's, like if you plot them on your polar axis, your R's are above, they're actually on the axis. It's because it says XY axis that you would say it's below. Yeah, let me quick review. So your R's, okay, this is distance from center, or distance from pole, or distance from origin, all those words. If your R is positive and the values are increasing, then the distance is increasing. Yep, if it's a positive R and the values are decreasing, then the distance is decreasing. If it's a negative R, values are increasing, then the distance is decreasing. Good. And if it's negative and negative, value decreasing, then the distance is increasing. Okay? So we said this is kind of like if you use your product rules. Guys, shh. If they're both the same sign, it's increasing. So positive and increasing are increasing. Negative and decreasing are increasing. And if they are opposite signs, then they're decreasing.